So without further ado, let me introduce our keynote speaker, Lisa Trollo, from Artificial Intelligence Strategy at STMicroelectronics. After joining ST in 2012, Lisa achieved important results in the consumer, automotive, and industrial markets for MEMS and Sensors division in AMS Group. Among them, the best known is the massive IMU product deployment in the smartphone market. Since 2020, she has played a key role in the Artificial Intelligence Strategy in MSD division, where she manages the ecosystem and defines the AI strategy and roadmap. Let us welcome Lisa.
So, good morning, everybody, and thank you very much for the opportunity to talk about or to port the voice of the industry to the tinyML community. So, what is happening? So, today we have a continuous increase on demand of sustainable solution from the industry to the end user. So, it means that we must be all more responsible. And of course, it's essential to embed sustainable practice in our strategy of the company. And this is for sure for our people, our business, and of course the society at large. So, having this evolving context, to share the view of the industry, we start by analyzing the CO2 emission. And based on the International Energy Agency, we had 34 gigatons of CO2 emitted in 2020. And overall, this amount of number, the 40% is part of the power generation sector. That means, of course, the generation of the electricity. And then we have the heavy industry, we have transportations and infrastructures. And the humans has a big challenge in front of us, or let's say for all of us, that is achieved by 2050, the zero CO2 emission. And this is not just an option, a possibility, but this is a must to happen. And of course, some transformation are starting to happen very smoothly, very sharply. And the path to the net zero is for and all about people, all about us. As electronic component industry, we know from one side, for any production of our product, we need electricity. And from the point of view of the user, whatever they are buying, they need electricity. So any electronic components need electricity to work. So of course, we know we are part and we are protagonist for the needs of electricity. And what we are doing today. So, from the perspective of the industry point of view or the energy generation, we have already something that is put in place. And in fact, we are seeing the transformation from the fossil source to the renewable source. But this is not enough. Of course, as we said, there are other three sectors that are important, and they must put in place the measured transformations. And for example, in the industry, all the machinery must be equipped with very high efficient solutions. And for the transportations, okay, today we are seeing some electrical cars, but the change from the traditional engine to the electric motor must be fastened. And finally, for the buildings, the infrastructures, okay, let's say the infrastructures, commercial or whatever are for our flats. In this case, also we have to put in place solution where the energy efficiency is the max. No problem. So just a short recap about one of the big challenges that we have in front of us. And it's the path to the carbon neutrality. As I said, by 2050, zero CO2 emission is a reality, not a dream, it's not a possibility, but it's something that must happen. And so the industry at first has a key role to do this. And again, do you remember there are 4 different sectors that are the major contributors for the CO2 emission? One of these sectors, it's starting a transformation. Of course, the energy generation is the first one, where a lot of examples we can have in front of us, but also for the industry, the transportation, and the buildings. We are putting in place some countermeasurements. And if from one side we have this transformation, on the other side we see that the projection of the electricity that is needed worldwide will be 3 times more than the electricity needed in 2020. And this is basically generated by or driven by the decarbonization effect, so all the countermeasurements that we are putting in place, and of course the electrification for the transportation and the buildings, the infrastructures. So what do we do now? The path for the major transformation is already started. But we know that to achieve the goal, to have both the zero path for the CO2 emission and the electricity demand that must be lower as possible, it's by means no obvious. And let's see why. So to make the carbon neutrality a reality, having in mind the effect on the electricity that we need, we have basically to focus on 2 important areas, 2 important sectors. The first one are the renewable energy sources. And the other one is the energy efficiency at every level. We have to implement the energy efficiency. And the equation is very complex and not easy to solve. But we know that leveraging on new technologies, on innovations, we can for sure make better our planet, our world. And the semiconductor industries has, of course, a key role. They are protagonists because they can offer, at first, a very large-scale solution in a short time and grant the energy efficiency of the systems with their productions. So, I briefly introduce you the point of view of the industry. Let's change a bit. What humans really expect today and for the future from the technology? Well, the context is evolving very fast. And what at first, any one of us, when we are buying something that is related to technology, we look at today is the sustainability. So we buy something if we know that it can protect the planet. We want to live in a safe and healthy planet. And on the other side, the technology is, let's say, in our daily life. So we have a kind of fusion most of the time between the technological support and our everyday wellness, well-being, and whatever we want to call. And so the technology is for sure human-centered. So it helps in a not invasive way our daily, our wellness, making us maybe sometimes more secure. And it can also help us to create or, let's say, stimulate our creativity. And which is the role of the sensor in front of this new concept of the technology? Of course, also the sensors are at the heart of this new era, new future that is coming. And at first, sensors are for sure human-centered, because by default, by their meaning, the sensors are the bridge between the reality and the digital world. They are able to sense something that is physically measured and change it in a digital world. And on the other side, they must be sustainable. So we have to offer to the market sensors that are smart, that are able to, let's say, anticipate the human expectations and do everything in a very sustainable way. So we are entering in a new era, in what we call in ST the sustainable on-life era. So a couple of years ago, we entered in the on-life era. That was exactly the period where we have the complete fusion between the technology and the human life. And the sensors were not only able to sense, but also to think and act, and continuously sending to the cloud with an always-on configuration the information. But now we are saying we are in a new era, or we are entering in a new era, that is the sustainable on-life era. And in here, the sensors are, of course, able to sense, think, and act, but they are also able, based on the always aware capability they have embedded, to send to the cloud only the meaningful data. So only those data that are really needed to the cloud. And which are the attributes for a sustainable on-life era for a MEMS sensor? 3 important attributes: smart, open, and accurate. So fusing these 3 important attributes together, we can for sure grant the sending of the meaningful data, only those data that are needed, to the cloud in a very optimal way. And looking at these 3 attributes, we can say that, of course, as we said before, the sensors are human-centered and sustainable. Let's start from the first attribute, so smart. If a sensor is not smart, what happens? All the raw data are continuously sent to the cloud. And of course, the throughput through the network is crowded. Data should be corrupted. You are missing the privacy. You are, of course, missing the security. And this continuous, let's say, throughput of data to the cloud is for sure not sustainable. And more data means more power. So we cannot continue to project, or let's say to have solutions where we have an always-on raw data sent to the cloud. This is not what the sustainable on-life needs. So let's be smart as an octopus. Let me talk about the octopus. So there are a lot of similarity between this animal and a smart sensor. So the octopus is able to learn from the environment. And this is exactly the same for a smart sensor. He's able not only to sense, but to think and act, thanks to the AI that is embedded in it. Then the octopus has a lot of neurons in his tentacles. So the brain, in case of the octopus, is exactly in the edge. Coming back to the electronics, if we think about a system, exactly it's the same. The smart sensor is like the tentacle, and so it has the brain in the edge. And finally, the octopus can vary its forms and colors in a different flavor and type. And this is the same in a smart sensor. So a smart sensor is flexible and can be programmed according to whatever is the context all around, in order to be always aware. So a smart sensor, for sure, can be a good solution for the sustainable on life. Because, again, with the AI in the edge, we can send only the meaningful data to the cloud. So the throughput is no more a problem. We don't need too much complex infrastructures, and moreover, we have the best energy efficient system. So, coming back to the octopus, maybe a lot of you know that more than 60% of the intelligence in the octopus is exactly in the tentacles. And what happens in an octopus is that the tentacles has, let's say, a first classification of what is happening all around, and then only the meaningful data are sent to the head. So this is the same on a sensor node, or let's say in a system. We have the smart sensor that can have a first classification about the context, about what is happening, and then only the meaningful data is sent to the head, like the MCU or the cloud, and you have the best efficient solution. So what did we do in ST for the smart sensor? We adopt basically two different philosophy or two different flavor of AI in the edge in a sensor. The first one is the machine learning core, MLC. And this is a hardwired solution in the digital portion of the sensor. And it can enable possibility to classify only with decision tree classifiers, more than one in parallel. And if you succeed to have an algorithm embedded in a machine learning core, for sure this is the lowest power consumption solution that you can achieve. On the other side, we offer also another approach that is the Intelligent Sensor Processing Unit, ISPU. In this case, we are talking about a DSP that is, again, embedded anyhow in the digital portion of the sensor and gives you more flexibility on the programming, because whatever is the classifier that you want to fit in, you can do. Of course, with the limitation of the dimension of this very tiny piece of silicon, but you have flexibility to do. You can program in C language, and thanks to a tool chain, you can embed it in the sensor. You have more flexibility, as I said. Of course, the trade-off is a bit more power consumption as final solution. Anyhow, both of the solutions are having in the order of microwatts or microampere of power consumption. Let's now go to the second attribute, as I said, open. In ST, we believe that opening a sensor to others is a good way, a good path for the energy efficiency overall in a system. And to enable this concept of open, we pursue two different ways. The first one is the sensor hub, and the other one is the open ecosystem. For the sensor hub, it means that all our smart sensor has capability to connect up to 4 external sensors. It doesn't matter if the sensors are not ST. We are open and we want to host those sensors, providing capability to receive those data from the external sensors and also to process this data directly in the AI portion of our sensor. So at the end, we can enable the capability of a sensor that is not intelligent to become intelligent, always at the sensor level of the system. And this gives a very good power efficiency solution. Open ecosystem. So we don't have to think that we have to do everything by ourselves and alone. So we want to offer a MEMS ecosystem open. That means partners or customers can put their state-of-art know-how, their IPs, silicon, and we know that having this synergy between the sensor capabilities and partners and customers, we can for sure offer the best flexible and sustainable solution. And last but not least, offering also a very quick and good time to market. The last one attribute, that is the accuracy. Accuracy, we know, is a topic that will never end. Or let's say, year by year, the accuracy in a sensor at least is one of the key factors. And we worked for 25 years, and we will work for more and more years to improve, always improve the accuracy. As of today, what does it mean, the improvement done in the sensor? It means that if we achieve a good accuracy, we can send polished data to the cloud. And so running maybe more complex algorithm at the sensor level, we can guarantee good data to the cloud. And moreover, if we increase more and more the accuracy of a sensor, we can also be very good to mimic the human senses. Because, as I said before, the sensor is the only bridge between the physical reality and the digital world. And if the sensor is very accurate, it can also anticipate some human expectation. And at the end, of course, when we improve the accuracy, we can allow for sure an energy saving of the system. Just a practical example, if a customer knows that the sensor is super accurate, he can skip, for example, the factory calibration. And this is, believe me, a very good advantage that we can offer to any customer. But as I said, the accuracy is an always exploring activity. And if we look to the path of the energy efficiency across the flexibility in the sensors, of course, we can see that in the past we start to have more accuracy adding just an embedded processor. But we understood that the embedded processor was, let's say, an overkilling solution to a sensor. So we have done, at the industry level, of course, some activities to have integrated DSP with a sensor. And in this case, we reduce a bit the flexibility, but we improve the energy efficiency. But what's the future? As I said, accuracy is always improving and improving. And the future is based on the reconfigurable processor. So a solution, a dedicated solution where, again, the flexibility is a bit limited, but it can give you the best energy efficiency solution. And at the end, if we want to change from microwatts to nanowatts, it means that we have to focus more and more on the technology combined with artificial intelligence. Let me show you an example of an exploration that we have done in ST. So we took the challenge to implement a tiny self-calibration in a sensor. And to do this, we decided to implement an AI algorithm with some clear challenge, or let's say goal. First of all, the sensor specifications were very clear, and of course the results was not acceptable to be less good than what today we have. The technology, no change on the technology. Release something very tiny in terms of silicon area, because a sensor package cannot change in the market. At the end, we succeed on implementing a reconfigurable hardware directly inside the digital portion of the sensor, where an AI algorithm, very tiny, is running, and of course providing this self-calibration embedded. And the result is that in terms of energy efficiency, we are talking about 50 nanowatts, so an order farther than today. And the memory needed for the AI algorithm is just 8 bytes. And of course, the area needed to implement this solution is only 0.03 millimeter squares, of course, with the technology that today we are using for sensor. So let's be very pragmatic. Okay, we talk about the carbon neutrality, which are, let's say, the attributes of the sensor for the sustainable on life. But what can we really do? So we have done some exercise just to give you an idea. And we took a use case that is related to this, let's say, smart buildings or our offices. Today, a lot of the offices are not smart, are not intelligent, in particular for the lighting. So even if there's nobody in the office, the lights are on. So we make an exercise considering to replace, let's say, the 90K of the offices worldwide with an intelligent sensor, being able to detect if there is really a presence of a person or not, and estimating to turn off the light just 1 hour per day with this intelligent mechanism, well, we can save up to 264 kilotons of CO2. And this is just the first example. Let's go to another example of our daily life. All of us, we have the laptop. And at least once we experienced that we put our laptop in the bag, and maybe when we took it out, it was, of course, burnt, and the battery was exhausted. And this is because after turn off the PC, maybe we closed it too much earlier, and the system didn't go in power down or switch off. Another example, we have our PC in the table, but we are not using it, but it continuously drains the battery. Or finally, you have your PC in your legs, and you are burning your legs because the fan is working too much, and the system is not able to go in power down. So with just one smart sensor, and with some AI embedded with the machine learning core, we can detect all these different use cases. And considering to replace to all the laptops worldwide with this one sensor and its intelligence inside, the tiny intelligence, we can save up 70 kilotons of CO2. And finally, let's go to one of the activities that at least once, or better 3 times per day, we do, that is brush our teeth. So with an intelligent sensor that is able to directly, locally understand what kind of movement you are doing without having continuous raw data going to the cloud to understand what is happening, in this case, having all the electric toothbrush with our smart sensor, we counted around 1 k tons of CO2 saving. I know the numbers are small if we compare the 34 gigatons of CO2. But if we consider all the smart objects, thousands and thousands of smart objects that we have worldwide, well, also with this simple example, with this simple decision of power saving, we can save our world, or let's say, making something good for our planet. So, as an industry, we have an important responsibility. We have to provide, in a fast way, new technologies that help worldwide to deploy sustainable solutions to protect our planet. We know we are in the sustainable Onlife era. That means we have the fusion of the technology with our daily life, and we have to implement the energy efficiency at every level. And of course, leveraging on sensors that are smart, accurate, and open, we can grant it a sensorization of the world that is sustainable. Okay, I want to conclude with one message that, in my opinion, is a good ingredient for the tinyML community and the industries. And this is a proverb. It takes a village to raise a child. So it means that if we want to grow up a child in a safe and healthy environment, it means that all the community should work to make this happen. And this is the same for the sustainable Onlife, or the sustainable planet, or the sustainable solution that we want to implement. The community has to work with the industry to make it happen. So, thank you very much.